So let's finish up that one square root thing that we talked about. So I have it in my notes right here. I'm not going to write out the whole problem. Let's just write out the algebra part to it. So I think we use different letters, but if you remember, the hypotenuse is equal to the square root of 2 times the leg. Do you remember that? And then I think on that problem, is it the same problem? The hypotenuse was 12, is that correct? Was it? Do you have your notes? Did you write it down? In my notes, I have 12. Anyway, I'm going to do it anyway. So I'm going to just draw a sloppy little right triangle right here. So if that's 12, and it's boom, boom. Yeah, it's isosceles triangle. That's 12. I want to find one of the legs. So we'll just call it L for leg. All right. So what's this one down here going to be? It's also going to be L because they're exactly the same thing. All right. So what do? We put a 12 in for that. We hit square root of 2. Well, we already got L for leg, right? So what are we going to do to get leg by itself? Divided by the square root of 2. Divide this by the square root of 2. But this is where we left off yesterday. All right. Or at the part that we were talking about yesterday. You can't leave it like that. There's a reason, I'm not going to get into it, but mathematicians do not like having a square root in the denominator, right? They consider it not simplified. It's just like if you would say this. If you would say 2/4 is your answer and you would circle it. Do math teachers like that? No. What do you have to write your answer as? 1/2. It's simplified, right? It's the same idea here. All right, and I threw out the word yesterday. I did it very quickly. You probably don't remember it, but it's called rationalizing the denominator. All right, rationalizing the denominator. So that means, well, it just means basically you can't have a square root in the denominator. So let's come over here and show you what we can do to get rid of the square root. Let's go back in time a little bit. If I took the square root of, 5 times the square root of 5, what does that equal? You can look at it a couple different ways. You could say, well, it's the square root of what? 5 times 5, which is what? 25. What's the square root of 25? It's just 5. Or you could look at it like this. This is something that's being multiplied by itself, isn't it? You see that? So what do I do when I multiply something by itself? Like 2 times 2, 3 times 3, 4 times 4. What am I doing? I'm squaring it. That's right. So square root of 5 times square root of 5, isn't it the same as the square root of 5 what? Squared. Isn't that the same thing? All right, so I could look at this two different ways. What happens when a square is over a square root? They cancel each other out. What am I left with? Just a 5, okay? So how do I get rid of a square root? Okay, I could square it, okay, or I could multiply it by what? Itself. That's what I'm going to do for this right here, okay? So what I'm going to do is I'm going to multiply this fraction. How do I get rid of that square root on the bottom? I multiply it by itself. That'll get rid of it, correct? But I can't just do that to the bottom just randomly. I'm also going to have to do what? Do it to the top. Why? Is it the rule that says whatever you do to one side, you do to the other side? Is it that rule? It's not that rule, okay? What is this thing right here? What does that simplify to be? What's anything divided by itself? What is it? It's 1. It's 1. Anything divided by itself. 3. 3 divided by 3 is what? 1. 87 divided by 87 is what? 1. What's the square root of 2 divided by the square root of 2? It's 1. So really, all I'm doing is just doing what? Multiplying this fraction by what? By 1. All right? Am I allowed to do that? Sure, I can multiply anything by 1. It still stays the same, doesn't it? All right? Yes? But why did I use the square root of 2? Why didn't I just say times 1? Well, that wouldn't really help me out. I'm doing square root of 2 because if I multiply this square root of 2 by a square root of 2, what does it do? It gets rid of the square root of 2. Or it gets rid of the square root, I should say. You with me? Okay, so what's the square root of 2 times square root of 2? It's just 2. That's it. Now, what's the top going to be, though? Exactly, 12 times the square root of 2. Do we circle that? Is that our simplified answer? Is it? Yeah, we can. What do we do? Divide by 2. Divide this by 2, that's a 1. Divide this by 2, it's a what? 6. So what's my simplified answer then? 6 times the square root of 2. So it's kind of weird, that 12 divided by the square root of 2 is the same exact thing as 6 times the square root of 2. If you have a calculator, put it in. It'll give you some decimal number, but it'll be the same number. It'll be the same exact number on your calculator. If you put 12 divided by square root of 2 and you put 6 times the square root of 2, it's the same exact number. Okay? All right, you learned some algebra today. How's that? Good. Now when you take algebra 2, now whoever your teacher is, you're going to say, oh yeah, Mr. Hamrick did that in geometry. I got that down. Right?
You're the teacher, we don't have to say it.
Yes, you have to say it. If I'm your teacher. All right. I don't know if I am or not, but I'm sure you don't want that, but you might learn something. I don't know. You didn't sound very enthusiastic yesterday when I mentioned that could be a possibility. I kind of felt a moan amongst the crowd. I don't know. So anyway. Let's do...
We have geometry too?
No. Oh, wait a minute. Let's do this. I'm going to show you. We're going to kind of do a little proof here. We did that on the 45. Do you remember we went through a whole process to figure out why the hypotenuse was the square root of 2 times one of the legs? Do you remember that? All right, it's in your notes, if you took notes. It's on YouTube if you want to look at that. So what I'm going to do here, this is an equilateral triangle. Yes, it is. It's an equilateral triangle. But what I'm going to do is I'm going to take this and drop it straight down. When I say drop it straight down, I'm dropping it perpendicular. So that's a right angle. Everybody with me on that? So if it was an equilateral triangle, what is this angle right here? It's 60. Very good. See, Roger? They know that that's 60 degrees. All right. What did I do to this big angle up here? Now, what's this angle here? That's 60. What's this angle right here? That's 60. Okay. What's the little angle right here that's caused by that perpendicular? It's be 30, right? Because it split it into equilateral triangles. We're not going to talk about that. But yes, this would be 30 degrees right there. So check out what kind of triangle I have here on the right anyway. I have a what? I have a 30, 60, 90 triangle, right? There's my 30, there's my 60, there's my 90. Everybody with me on that? So what? Let's just show that these two angles are equal to each other. It was equilateral, so those two are going to equal each other, right? And that whole bottom is going to equal this, but if I hit it perpendicular, where is it going to hit? It's going to hit at the midpoint. That's right. So that means that one and that one are equal. What's also shared by both of these? This one right here. So are those triangles congruent to each other? Yes, they are. Why are they congruent to each other? Side, side, side. You got it. Okay. So those triangles are congruent. So that means that that angle and this angle have to be the same. Yes? All right. If the whole thing was 60, that's 30 and that's 30. There you go. So there's a little bit of proof on why the triangles are congruent. All right. Why do we want to do that? So what we're going to do is this. We're going to just take the right triangle. I'm just going to redraw it so I don't have all that mess over there. I'm trying to make it kind of look like, might not be exactly, but you get the idea. All right, this is the same triangle as this one right here. Yes? What I want to do, let's put the angles in here. So that's 60 and this is 30. So there's my 30, 60, 90 triangle. What's really interesting about this is this. Let's just try to make this easy. Okay. What if I said that the hypotenuse was equal to 2? I'm taking it from this triangle. Okay, remember that. All right, it's an equilateral triangle. So if I made that 2, everybody see that? I just redrew this triangle over here. That's all I did. What's this bottom one going to be? Now remember, we already talked about this. What's that whole side right there that I just drew with the brace? What's that whole side? It's an equilateral triangle. What's that side? Come on, quick, before Roger gets mad at you. All right, it's 2. Thank you. All right, what's this side going to be then? If this whole thing is 2, that's going to be 1. Would you agree? Because it's split in half. All right, so what's the side right here? That's 1, okay? So if that was 2, this is 1, right? Or the other way around. What if I told you this was 1? This would be what? 2. Now, what's true? We call this, they're 2 legs, but remember on the 45-45, both legs were what to each other? They were equal to each other, okay? Because it was a 45-45, right? And the 2 sides are equal. But these 2 legs right here are not equal to each other, but there is a relationship between them and the hypotenuse, all right? So this is considered the short leg. How do I know it's the short leg? Just because it looks shorter? I mean, that's a pretty good idea, but there's a geometric way. There's a way that we've learned before. You got it. It's opposite the shortest angle. Take that, Roger. All right. So it's opposite the shorter angle, the smaller angle, okay? You with me on that? All right. So I call this the short leg, and I call this one right here, what do you think? Let's call it the long leg. Or the longer leg. We'll just say long leg. All right? Everybody with me? What do I call this side right here? How do I know that's the hypotenuse? Very good. You guys are catching on. It's opposite the right angle. Okay? Now, there's a relationship. This is kind of interesting. Let me push this over off to the side. All right, there's a relationship between the short leg and the hypotenuse every single time. Not just on this particular one, but every time you have a 30, 60, 90 triangle, this is the relationship between the short leg and the hypotenuse. So let's do it like this. The hypotenuse is equal to what times the short leg? 2 times, exactly right. So 2, I'll put a little X for multiplication, okay? So hypotenuse is equal to twice the short leg. So what if I told you I had a 30, 60, 90 triangle and this was 5? This short leg was 5. What would the hypotenuse be? Quick. If the bottom was 5, what would the hypotenuse be? It would be 10. Because why? Hypotenuse is twice as big, right, as the short side. The short leg, I should say. Does it make sense? Okay, what if this short leg was 3? What's the hypotenuse? 6. You get the idea. What if the hypotenuse was 14? What's the short leg? It's 7. Everybody with me on that? All right, that's pretty easy to see. That's the easy part. There's a second part because the legs are different, right? You got 2 different legs. They're not the same. On 45-45, you only had one thing. You had the hypotenuse was equal to the square root of 2 times the leg. One equation. On this one, we're going to have 2. This is our first one. That's the easiest one. So now what we're going to do is we are going to try to find a relationship between the long leg and the short leg. This is a number that I really, really doubt, unless you look, that you're going to come up with this number unless you do some math with it. And we can do some math. Since we have a 1 and a 2 right here, let's find what the long leg is equal to. How can we do that? What's this whole lesson called, by the way?
Special triangles.
Yeah, and what was yesterday's lesson called? Or the lesson before this one? Pythagorean theorem. Pythagorean theorem. So I've got a right triangle. I've got 2 sides of my right triangle. All right, and I want to find the longer leg. Let's just call it L for long. Is that all right? So, what's that? Yeah, Mom? Okay. So let's do some math. Let's do some Pythagorean theorem and find out what the length of this long leg is. Okay? Everybody with me? So let's do it. What do? L what? Squared plus 1 squared equals 2 squared. Good. All right, let's do this. This is L squared plus, what's that? What's 1 squared? 1 equals what? 4. Subtract 1, so L squared is 3. Now, this is not 3. What is it? Exactly right. It's the square root of 3. So the long leg is equal to the square root of 3. See how I set up my little formula right here? So the long leg is equal to what? The square root of 3 times the short leg. Would you agree? All right, because it's square root of 3 times 1, which is square root of 3. So the long leg is the square root of 3 times, I'll put a little X right there, times the short leg. This is the thing that you need to know about 30, 60, 90 triangles. All right? Everybody with me on that? So we basically have three things to know, but two special triangles, right? So what did we know on the 45, 45, 90? The hypotenuse was what? The square root of 2 times what? One of the legs. Doesn't matter which leg. No, because both the legs are what? They're equal. They're the same, all right? So this is the formula that we learned for 45, 45, 90. And this is the formula, two formulas that we learned for 30, 60, 90. Why do we have two? Because both legs are different, okay? Right here, why do we only have one? Because both legs are the same. We only need one equation, right? So this is something that you should remember, all right? It's very, very helpful to you instead of going through the whole Pythagorean theorem thing, all right? So let's do a little example. All right, this is example 3. All right, I'm tired of looking at white on black. Let's add some color to this. What's that? You think? Pink. You like pink better?
Yeah.
All right, we'll use pink. I kind of like how that shows up on the black. It looks kind of nice. All right, so this is example 3. Let me draw the triangle. Draw it like this. I'm going to try to make that as much of a right angle as I can. It might not be exact, but it's good enough, because if we mark it with a box, then what kind of angle is it? It's a right angle. All right. Tell you what, I'm just going to put some letters in here. We'll call that X. We'll call this, well, this is supposed to be a lowercase, but I'm going to write it like that. And this is 12. Oh, we did 12 again. And this is 30. And this. Now, if I didn't tell you what this angle was, could you figure it out? Yes, what is it? It's 60, right? Okay? Because 90 minus 30 is 60. Or vice versa. If I gave you that 60, you should be able to know that that's 30. Agreed? All right. So there's a triangle, and we want to solve for x and z. So let's do that. Well, what do they tell you? Wait a minute, did I... Yeah, we're good. So, if you notice this, here, let me go back to this. Did you notice that both of these are something times the short side? So the short side is the important side, because this one is twice the short side. This one is the square root of 3 times the short side. So the short side is very, very important. Would you agree? Yep. So let's see. What do you think you want to solve for first? The short side, okay? Because I can't really solve for z right now, all right? Because do I have a relationship between the hypotenuse and the long side? Do I? No, I only have the relationship between the hypotenuse and the what? The short side, and a relationship between the long side and the what? Short side. So the short side is important, okay? I want to make sure that it kind of helps you when you're solving for this stuff. So let's solve for that. And what do we know? We know the hypotenuse. So we know the hypotenuse, we know the short side. When you're first doing these things, I would write this down every single time you do it, all right? If you have 5 problems where you have to do this, I would write it down 5 times, because that way you're going to remember these formulas, okay, instead of just sitting there looking at your notes and trying to memorize them. If you write them down, it's going to be so much easier for you to do that. Can somebody get that door, please? All right, so what's our little equation or little relationship between the short side and the long side? The long side, it's the last one we just did. What is it? Without looking at your notes, the long side is what? Square root of 3 times what? The short side, right? And we'll put it in the x in a second.
It's kind of unrelated, but it's important.
I'm sure it is. You got to go to the bathroom.
No,
Okay.
Really important.
What is it?
So, yesterday I was talking to some kids in the driver's ed class, and they said driving the period after that. Is it cool if me and Kevin go take some pictures?
That's fine.
He got it.
Well, somebody else driving. Well, ask the driver's ed teacher.
I had them ask the driver's ed teacher.
And is he okay with you riding in the car? I don't know if I need both of you, though, in the car, though. Well, you need to ask him, though. Well, of course, he's not going to let you in just walking in the car, but say something to him, is it possible? If not, then just get if not, if you can't get in the car, just get pictures of them like from the outside sitting in it, or maybe just have the car parked. You get in the back seat, take some pictures with the kid, with his hands on the wheel or something like that, just to make it look like he's driving. Okay, or just drive around see if the driver's ed teacher doesn't mind just driving around the parking lot with you snapping some pictures. Okay, all right. Okay, here we go. So let's put some stuff in. So what's the long side here? It's 12, right? What's z? Z is the what? Z. So it's the hypotenuse, okay? Now, it's the longest side of the triangle, but that's always the hypotenuse, okay? So this is the long leg. Everybody got it? So I'm going to put a 12 in right there. Put in square root of 3. Put in short. What's the short leg? It's x. So now I just do my math. All right, so what do? Divide by square root of 3. This looks familiar, doesn't it? All right, so let's simplify this. I do want you to simplify it. I mean, this is honors class. You should know how to simplify this, okay? So I'm going to put 12 over square root of 3. What do? Multiply by square root of 3 on the top and bottom. Why do we do that? Because of this step right here. Square root of 3 times square root of 3 is just 3. And this is 12 square root of 3. Do we leave it like that, though? No, because 3 goes into that, 3 goes into that, so it's what? 4 square root of 3. Okay? So that's what x is. It's 4 times the square root of 3. And that's important because that's my short side, all right? And both of these things relate to the short side. The long side relates to the short side. The hypotenuse relates to the short side, all right? So now we should be able to solve for z. Tell you the truth, you could, if you wanted to, do Pythagorean theorem and solve for z now, couldn't you? Okay, but do you really want to put that into Pythagorean theorem? It really wouldn't be that hard, but now let's do the way that we just learned. So the hypotenuse, what's the relationship? I'm going to write it down. The relationship, hypotenuse is what? 2 times what? The short side. Okay, now I know the short side, right? And z is the hypotenuse, so it's 2 times what? The short side, which is 4 times the square root of 3. So I'm multiplying those together. And that's super easy. Isn't that way easier than doing Pythagorean theorem? Yeah, absolutely. All right, so z equals what? 8 times the square root of 3. And that's how I want you to leave your answer. I do not want you, put x right here. I don't want you to put it into a calculator and get a decimal answer. Now, in real life, okay, if you're measuring something out, if you're a carpenter and you had to figure out what the length of this side is, you're not going to say, oh, it's 4 square root of 3, and then go to Lowe's, like you said yesterday, right? Go to Lowe's and say, I need 4 square root of 3 feet of lumber. The guy at Lowe's is going to say, what are you talking about, right? You're going to put it into a calculator, get a decimal, and get that much lumber that you need. Everybody understand that? All right, so, but this is not, quote, real life. We're just learning math, okay? We're just trying to simplify some things, all right? And there are really important reasons sometimes just to simplify radicals or square roots, all right? But like you said, in real life, these are the lengths of certain things, and we can measure it out. We can cut it to a certain length. Yeah, and we would put it into a calculator. But this is math class. I don't want a calculator answer. These right here are exact answers. A calculator answer would be a what kind of answer? Okay, not an exact answer. Give me a good word. Starts with A. Approximation. It's an approximation, okay? So because it's going to have a decimal, and the decimal is going to keep on going, right? And so it is irrational. Did you say that, Hunter? Okay, yes, it would be an irrational number. These are irrational numbers, but it would be a decimal that just keeps going. All right, let's see. I got another paper. Let's see what we got on here. So now we're going to go back to area. All right, you tired of pink yet?
No, actually do blue.
Blue? Okay, yeah, blue is soothing. All right, another equilateral triangle. We got time? Yeah, we got time. 5 minutes. Let's make this into a triangle, equilateral. Just make it a little bit bigger. All right, here's what they give you. It's an equilateral triangle, and all. They don't even give you a number. No, okay, it's, tell you what. They give you a little formula for the area of an equilateral triangle. I think there's no way you're going to remember that. So what we're going to do, we're just going to do the work on it, all right, instead of come up with a formula. So this is example 4. And they tell you it's an equilateral triangle, and each side is what? 5. Okay? Everybody with me on that? So what could you do? How would I find the area? That's what they asked for. Did I say that earlier? Find the area. Well, it is a triangle, so what's the area of a triangle? It's 1/2 what? Base times the height. What do I already know? I already know the base, don't I? Which is what? 5. All right, so I already got 2 out of the 3 things that I know. So all I got to do is find the what? The height. So where is the height? Let's change colors. It's from here, what? Perpendicular, and to the what? Midpoint. Agreed? So since it was an equilateral triangle, how many degrees was this? 60. We've already discussed that, and that was 30. We've already talked about that. So what do I want to find? I want to find that green one right there. That's the height. All right, so we're just looking at the right triangle right now to find the height of that right triangle. All right, what's the bottom from here to here? What's that? It's 2.5, right? So let's just put. Let's not put 2.5. Let's put what? 5/2. All right. It's just, to me, it's a little easier, to tell you the truth. So we can do this without a calculator. All right, everybody with me? So now, look what we have. What is this side right here? We could do Pythagorean theorem if we wanted to, right? We could go h squared plus 5/2 squared equals 5 squared. We could do that, but we learned something. We learned about 30, 60, 90 triangles. What did we learn? That the longer side, this is the long leg right here, the long leg equals what? 2 times the long leg. Square root of 3 times the short leg. What's the short leg? 5/2. So look at that. There's my height right there. It's just write it nice. It's 3 square root of 5, what? Over 2. Everybody got that? Yes? I didn't put it on the bottom. Put it on where? On the 5, it's times. It's multiplied. It's square root of 3 times 5. Oh, I'm sorry. I know what you're saying. That was pretty stupid. Thank you. Man, I would have really messed that up. You're right. Absolutely right. Good thing you caught me. Can't believe this teacher teaches a geometry class or a honors geometry class. You got a teacher that can't even get this right. You're absolutely right. It's 5 what? Times the square root of 3. I was blanking out there. All right, so that is your height. Yes? So where can we put that? Put it right there. So we put what? 5 square root of 3 over 2. Now, we just do some arithmetic is all we do. What's on top? A 1 times a 5 times a 5. Whoop, 5 times 5 is 25. What else is on top? Square root of 3. What's on the bottom? 2's on the bottom. 2's on the bottom. 2 times 2 is, that's your answer. That's the area. Now, if they give it to you like in inches, you would always put what? Inches squared because it's area. It's a weird number. I get it. Again, if you're going to go out and you're going to buy some lumber or carpet, usually carpet they sell in like square feet or square yards or something like that. Yeah, you would put it into a calculator and figure out how much you needed. But this is math class. We're just going to simplify the square roots like this, and that's how we're going to write our answer. Okay? I'll tell you, I'll show you the area just so that I show you. This is a formula that I don't have memorized, to tell you the truth, because I could always just do the work and come up with it. But there is a formula for the area of an equilateral triangle. I mean, this is a pretty specific formula, all right? And here it is. It's the square root of 3. I got to look at it. Over 4 times the side. S represents the side squared. So let's just see if that actually works with this. Now, if you knew this formula, then it would be kind of easy to do, wouldn't it? All right? But I don't know. Can you memorize that formula? I'm sure you could. But I would just rather do the work and get it. You know what I mean? And knowing stuff about 30, 60, 90 triangles. So let's see if this actually gives you the same thing. This is the area. So it's the square root of 3 over 4 times s squared. So what's s? It's 5, which is what? 25. Is that the answer that we got? Yeah, we just switched the order, put the 25 first, over square root of 3, or times square root of 3 over 4. That's the exact same thing that we got, all right? Would it have been nice to memorize the formula? Absolutely. And if you want to memorize it, feel free, all right? Not saying that you shouldn't, okay, but you don't have to. You can see right here that you don't really have to, all right? I don't think I gave you any homework yesterday, did I? So let's do, was I supposed to give you homework on the lesson plan? I think I was supposed to, wasn't I? Yeah. Yeah, I'm not going to give you all that. That's too much to do. So we'll just get one. No. You're definitely going to have homework. But it's section, what, 7-4. We'll call it A. And we're going to do 1 through 16. And then tomorrow we'll do what we're supposed to do today. Yeah, that works because I didn't really have a new lesson for tomorrow anyway. We're just going to review for a quiz. So it works out. In the end, it'll work out. We'll still stay on track. Okay? Everybody say, bye, Roger. Okay, 1, 2, 3.
Bye, Roger.